Hey guys, how you doing? So welcome to the fifth and final video in this chemistry series. We're going to take a look at chemical equations and what they are, and then how do we balance a chemical equation. So let's jump into it. Okay, chemical equations. So chemical equations represents that change and interaction between atoms and their electrons. And this is not the first time you would have come across this, because throughout this entire kind of video series, I've been sort of throwing out chemical equations every now and then to represent what's actually happening in our chemical reaction. Okay, and so you would have seen it before between bits and pieces here and there, and now we're going to give it a bit more time and see how we go. Okay, so here is an example of a chemical equation. Okay, now what I've done is I've labeled it and I've split the arrow in the middle. Okay, so what we've got is you've got magnesium 2 plus with in brackets S plus 2 Cl minus in brackets G with an arrow pointing to the right, MgCl2 in brackets AQ. Okay, now the first thing to establish is that arrow is your middle point, and everything on the left of the arrow is what we call the reactants. The reactants are the ingredients. It is what is going into your chemical equation. It is what is being used up in your chemical equation, and it's what forms your products. Okay, your products is everything on the right of the equation coming out on the other side. The products are formed by using up the chemical reactants. And in this particular case, the products is MgCl2, and then the reactants are Mg2 plus and Cl minus. Now, if you remember, 2 plus and then the minus, Mg2 plus is a cation, and this is an anion, and therefore this reaction is an ionic reaction. Okay. Now, there's a few other things here, so let's go through what some of these things actually mean. The first is the small number down the bottom. Okay, to read this number 2 is attached to chlorine. Yeah, it's telling you that there's 2 chlorine atoms for every magnesium atom compound. Okay, so this is one whole compound. This is one whole magnesium, 2 chlorine attached to that magnesium, and that's one little unit. Okay. Magnesium chloride is a salt, right? And so that little 2 represents the number of atoms present in a compound. Okay, so each magnesium chlorine or chloride compound contains 2 chlorine atoms, and that's what that little 2 represents. The big 2 tells you how many compounds there are. So in this particular case, there are 2 chlorine compounds. Because chlorine is kind of standalone on its own, it's a little bit confusing, but what this means is that everything after the 2 will be multiplied by the 2. In this particular case, it's just chlorine. If I was to chuck a 2 in front of the magnesium chloride, then I would have to multiply both the magnesium by 2 and the chlorine, which already has 2, by 2 again, giving me 2 magnesium and 4 chlorine in total. Okay, so that's worth remembering. Okay, the third thing, this little bracket tells you the state of the matter. So S stands for solid, which means magnesium coming into this reaction was a solid. Chlorine coming into this reaction was a G, a gas, and magnesium chloride coming out of the reaction is what we call an aqueous. In other words, it dissolves in water and will separate within water. If it was an L, it would say a liquid. Okay, so that tells you the state of matter in this reaction. Okay, there is one final thing worth mentioning, and that's the arrow here. Okay, the reason why it's a chemical equation and not a mathematical equation is because of this arrow. The arrow represents the direction of change, right? And most chemical equations that you sort of see will show an arrow that will point either to the right, or at times 2 arrows pointing in both directions, which tells you that the reaction can go one way and then swing back to reform its reactants as well. Regardless of which, we never use an equal sign, and the reason why we don't use an equal sign is because if you put an equal sign there, you're saying that everything on this side is the same as everything on this side, but that's not true in a chemical reaction. Okay, magnesium chloride is not the same as magnesium on its own as a metal and chlorine as a gas, because magnesium chloride has different properties. It has a different structure from the reactants, the constituents that it is made up of. Okay, so that's worth mentioning there. Okay, now when it comes to balancing equations, there are kind of two rules that you need to make sure that you maintain, because those two rules will determine how you go about your reaction. Okay, so the total number of reactant side must equal to the total number of on the product side. What that means is that you cannot create new atoms in your equation, and you cannot destroy any old atoms in your equation. It must be everything on the left must equal to everything on the right in terms of the number of atoms present. Okay, what that means is if I start off with 1 here, I cannot all of a sudden develop 2 on this side. If I have 2 the chlorine here, I cannot have 3 or 4 chlorine on this side. It has to be what we call balanced. Yeah, in other words, everything on the left equals everything on the right. Now, to get the numbers to become equal, you cannot just change any number you want. Okay, I can't just add a little 2 next to the chlorine here to make it balance. I have to only change the big number, what we call the coefficient number, or the number of compounds present. Okay, now the reason why you can only change the number of compounds is because it's only the reactants that can, the total number of reactants going into the chemical reaction that can be modified, not the individual atoms or elements. And the reason for that is because if you go kind of, if you sort of have magnesium and chlorine in nature, you don't just get one magnesium atom reacting with one chlorine atom. You have a whole sweep of them, millions of them joining together all at once to form a certain amount of their products. And so what we're saying is when we change this number here, we're changing the number of atoms, we're changing the number of compounds going into the reaction, but not the number of constituents. And that'll make a bit more sense when I explain it in the next slide. Okay, so let's go with an example. So what I've got here is sodium and water. Sodium is Na, and then water is H2O, and then they form a chemical reaction, and you can see here the change that's actually occurring. Right, when you put sodium in water, and if you ever do this as a demonstration, it actually looks wicked, and you should totally do it. You have sodium. What it does is interferes with the H2O bonds, and it will steal the OH from the H2O and join together with it and dislodge the H on its own. Okay. Now, in our chemical reaction, this might be what a typical unbalanced chemical equation would look like. Na, right? And H2O forms NaOH and H2. For the purpose of this, I've removed the pluses. Yeah, you kind of in a normal equation you'd put them there, but in this case here, I've just removed them to make it a bit easier for you to see. Now, what I tend to do is that I create a little table showing the total number of atoms in each side. Yeah, I split it in the middle, all the reactants on this side and all the products on this side. Okay, and so what you've got here is you've got the total number of sodium, you've got total number of hydrogen, and you've got the total number of oxygen in each side. Sodium, oxygen, and hydrogen. The first thing you need to know is that the reactant side must be the same. If I somehow have nitrogen there, I know that I'm doing something wrong in my chemical reaction. Okay, now let's jump around and we'll fill in the numbers, and that's what they currently look like. Yeah, you've got one sodium atom, you've got one oxygen atom there, and you've got two hydrogen atoms there. Remember that little 2 represents the hydrogen. You've got one sodium there, you've got one oxygen there, and you've got 3 this time, 2 here and 1 there. You might get this equation on its own, and then what you have to do is work out, well, how do I balance it? Now, what I can't do is I can't go ahead and change this 2 to a 3. I can't just do that because this is the subscript number, the number of atoms inside my compound. I can only change the big number here, but I've got a problem. If I want to change this big number to match the 3, and I put, for example, a 2 here, I actually multiply that 2 by the hydrogen and the oxygen, and therefore changing the number of oxygen present. Okay, so the method is I start with the number that is lacking first. In other words, I know that there has to be at least 3 hydrogen on this side, but I only have 2 on this side. So regardless of the way I go about it, I actually have to increase this number to 2 anyway. So I'm going to go ahead and do that. When I increase this number to 2, what I'm going to get is a new set of numbers on my reactant side, right? And so I now have to update my numbers. Now I have 2 hydrogen there, but because I've got 2 molecules of it, I have to multiply this number by this number, and I get 4. Okay. Now, the oxygen, there's only one oxygen in a water molecule, but there are 2 water molecules now in my reaction. And so I have 2 oxygen atoms in total, and my new numbers look a bit like that. Yeah, 1 sodium, 2 oxygen, 4 hydrogen, 1 sodium, 1 oxygen, and 3 hydrogen. It seems like it's not kind of working out at the moment, but I got to keep changing the numbers. So I kind of think, okay, how can I get this number to match 2 and this number to match 4? Well, I could increase the number of hydrogen, but that doesn't increase my oxygen very much. So what I'm going to do instead is I'm going to increase the number of sodium hydroxide. I'm going to put this number and I'm going to change it to a 2. Yeah, that bumps everything up by 2. A multiple of 2. I now have 4 hydrogen, 2 here and 2 here as well. I have 2 sodium there, and I have 2 oxygen there and there. And so now my numbers look like this: 2, 2, 4 on this side of the products, and 1, 2, 4 on this side of the reactants. And we close the deal by now fixing or changing this number of sodium to 2, giving me an updated number now. And so my reaction is now balanced. If I was to represent this in a chemical equation, it must look like this: 2Na plus 2H2O gives you 2 NaOH and 1 H2 molecule, right? What I'm saying is, in my chemical reaction, I'm going to have 2 sodium atoms joined together with 2 water molecules, and then that reaction will split them apart, and I will get 2 molecules of sodium hydroxide, NaOH, and 1 molecule of hydrogen gas, which is H2, okay? So that shows me whether it's an ionic bond, so it shows me how many is coming into my reaction, and it also shows me pretty well there that this is my covalent bond there, and then these are my covalent bonds there. I've got an ionic bond sitting in there with a covalent bond attached to it as well, and that is how I get my balanced chemical equation. Okay, so hopefully that makes sense for you guys, and you guys will have a great chance to practice some of that more in class. All right, so that pretty much wraps up the chemistry series that we're going on. It's a fairly short one with only 5 videos looking at this, introducing you guys to some of the methods in which we calculate chemical equations and so forth. I hope you guys enjoyed it, and I hope you're able to learn something new. All right, I'll see you guys later.